F1. Classify each pair of samples as independent or dependent. Let's remind ourselves what independent and dependent are. Independent are if the sample selected from one population is not related to the sample selected from the second population. And dependent is if each member of one sample corresponds to a member of the other sample. So for number one, sample one is the heights of 27 female students, and sample two is the heights of 27 male students. So since they're not the same person, they're not totally related, then these are going to be independent. So number one is independent. For number two, sample one is the midterm exam scores of 14 chemistry students. Sample two is the final exam scores of the same 14 chemistry students. These are dependent because each member of one sample corresponds to a member of the other sample, so that's dependent. And so you're going to need to be able to do that when decide whether they're independent or dependent, and that'll tell you which test you're going to be using. To try it yourself too. A survey indicates that the mean per capita credit card charge for residents of New Hampshire and New York is $3,900 and $3,500 per year, respectively. The survey includes a randomly selected sample of size 50 from each state, and the sample standard deviations are 900 for New Hampshire and 500 for New York. The two samples are independent. At alpha equals 0.01, is there enough evidence to conclude that there is a difference in the mean credit card charges? So the first thing we're going to do is just jot down all this data that we have. So we're going to call New Hampshire our first sample. So then our X bar 1 will be the New Hampshire mean, the sample mean, which is 3,900. And so New York is going to be our second sample. So X bar 2 is going to be the $3,500 credit card charges per year per capita. So the N1 will be 50, and also that's going to be the same for the N2. The sample standard deviation for New Hampshire is 900, and for New York the sample standard deviation is 500. And we have alpha is 0.01. And so let's start with our null and alternate hypothesis. So our null hypothesis is going to be equal to, because they talk about there being a difference. Is there a difference? So mu1 equals mu2 will be the null hypothesis. That's got to be equality. And the alternate hypothesis will be mu1 is not equal to mu2. The not equal to means it's going to be a difference. So if we accept an alternate hypothesis, then we say, yeah, there's a difference. Let's start with our critical values here. And we're going to go to our table 5. So it's going to be a two-tailed test. The reason it's two-tailed test is because we have this not equal to here. And so we're going to have a negative and positive critical region. So since our alpha is 0.01 and it's two-tail, we're going to go to table 5 here. And we're going to go to the two-tail, alpha 0.01, all the way down to the bottom, 2.576. So we're going to have a positive and a negative 2.576. There's our critical region. So now what we need to find now is we need to find our Z. So the formula for Z here, with two large samples, they're large because it's over 50, X bar 1 minus X bar 2 divided by the square root of the standard deviation squared, so the variance divided by of the first sample divided by N1, plus the standard deviation squared, or the variance of the second sample divided by N2. And so we're just going to put those numbers in there, and so we'll get 3,900 minus 3,500 divided by the square root of 900 squared divided by 50 plus 500 squared divided by 50. And so let's stick those in our calculator. 3,900 minus the 3,500 divided by square root of 900 squared divided by 50 plus 500 squared divided by 50. I'm going to close that parentheses. I don't think it'll really matter though. And so when we figure out what that's going to be, it's going to be 2.747. So let's put that back in there. We've got our 2.747. 2.747 is going to be in the critical region here, in the positive side of the critical region. Therefore, we're going to reject the null hypothesis, the H sub 0, and we're going to accept the alternate hypothesis. Therefore, there is enough evidence to conclude a difference in the mean credit card charges between New Hampshire and New York. One, try it yourself. 3. The American Automobile Association claims that the average daily meal and lodging costs for vacationing in Maryland are greater than the same average costs for vacationing in Colorado. The table shows the results of a random survey of vacationers in each state. The two samples are independent. At alpha equals 0.05, is there enough evidence to support the claim? So our claim is that Maryland, and we're going to call that the first sample, and Colorado is the second sample. So the claim is that Maryland has a greater cost than Colorado. So for our null and alternate hypothesis, since it's greater than, it doesn't have an equality to it, that's going to be the alternate hypothesis. This is going to be mu1 with the first sample, Maryland, is going to be greater than mu2 with the second sample, Colorado. So our null hypothesis is going to be opposite of that, which is less than or equal to. Mu1 is less than or equal to mu2. So this is going to be a one-tailed test on the right-hand side because it's greater than. And so let's go ahead and go to our t-table and look that up. Our alpha is 0.05, and we've got a one-tail test. This is a one-tail test. So let's take a look at that table. Alpha 0.05, one tail. So we've got one tail, alpha 0.05 gives us 1.645 as our critical value. Positive because it's on the right. Now let's take a look at the formula that we would use to this. Z is equal to x bar 1 minus x bar 2 divided by the square root sigma 1 squared divided by n1 plus sigma 2 squared divided by n2. Since we don't have the population standard deviation, we're going to use our sample standard deviations here. So that's going to give us 293 minus 286 divided by the square root of 22 squared over 150 plus 18 squared over 200. Let's take a minute and do that in our calculator. So we've got 293 minus 286 divided by the square root, second x squared, of 22 squared divided by 150, our first sample size, plus 18 squared divided by the second sample size of 200. We'll close that parentheses. And that'll give us about 3.1796, about 3.18. So let's find that on our curve here. 3.18 is way in the critical region. Therefore, we reject the null hypothesis. And in this case, our claim was the alternate hypothesis. So we are going to accept that alternate hypothesis. There is enough evidence to support the claim that the vacationing in Maryland costs are greater.